We are MTU's LiDAR-based bat hibernation monitoring system. Our team includes Adam Person, Garrett Smith, Spencer Fada, Ethan Baker, and myself, Max Heidecker. Our primary advisor for this project is Dr. Wayne Weaver. Our challenge given by SICK was to solve a problem using LiDAR. After research, the DNR was interested in additional help for counting bats. To the left, you can see a bat diagnosed with white nose syndrome. White nose syndrome is currently decimating bat populations across the United States by waking them up in the winter months where they go out to forage for food and starve to death. Their current method for counting bats in these stopes and caves is having an individual go in with a flashlight and count the bats by hand. Because of this method, it is highly inaccurate.
Our device's first use is to be used in big rooms of caves. The researchers will take the device in, set it up, leave it for the span of a week, return, take the device out, and use the data to create a 3D scan of the cave that will then have the bats located on it. The second use case will be to detect the number of bats that enter or exit a cave. The device again will be set up, left for a week, returned, and the data will be extrapolated from it. Our device uses a rotating 2D LiDAR to create these 3D scans. Some key features of our design include padding and the design to be used as a backpack to get to and from these caves, locating rings so the device can be used in the same location multiple years, and a battery to withstand the time requirement.
For use case 1 testing, we set the device up in a hallway and threw objects through the field. The results can be seen to the left. The red dots around the outside are representative of the wall of the filter, with the dots in the center being representative of the disturbance acting as the bat. For use case 2, we used a bat analog taped to the wall and took a 3D scan of the room using a servo motor with a 5-degree step interval measured from 0 to 145. The LiDAR can be seen in the red circle in the bottom of the right image. In the left, we can see the results of this test with the red arrow pointing to where the bat was representative in the scans. The results from our testing shows that we can see the bat in our scans, and we have taken our 2D LiDAR scans and compiled it into a 3D image that can be seen here. In the first use case testing, we had results of throwing 8 groups of objects through and being able to count as 8 disturbances. At the current juncture, we cannot distinguish between 2 objects being thrown through at the same time, but however, we can still identify that it was a disturbance. Other potential uses involve measuring the canopy density for the DNR, also replacing turnstiles in buildings as people enter and exit the building, and also for industrial uses, room dimensioning. This would allow us to replace expensive 3D LiDARs with a much cheaper version. Our next steps would be to assemble the individual components into a final prototype and conduct further testing at a higher resolution due to the stepper motor instead of using a servo motor. We would also like to do on-site testing inside mines and caves to get a better representation of our true conditions for use. Thank you.